In this video, we want to look at how to take a given trigonometric ratio and find the angle or angles associated with that. So, for example, let's suppose I was given that the tangent of some angle theta is equal to 1, and I wanted to know what theta was. Well, at first glance, you might say, I know how to do that, because all I need to do is go inverse tan on my calculator of the ratio, and out will come my answer. And if I do that, calculator is going to say 45 degrees. And that would be fine as long as we were only looking for angles between 0 and 90 degrees. But as you can see by my directions here, I want all angles between 0 and 360. And so I have to remind myself that for a given trig ratio, there are usually two angles associated with a given ratio. Two angles between 0 and 360 degrees, that is. So actually, the other angle here would be an angle in quadrant 3, and we know that it's in quadrant 3 because the ratio for tangent is positive, and tangent's positive in quadrant 3. And as we've discussed before, what these two angles have in common is that they have the same reference angle. So this reference angle would be 45, and therefore this angle would be 180 plus 45, which is 225. And so to check, I could go to my calculator and substitute these two angles into my original equation for theta. And remember to check that your calculator is running in degree mode, which mine is. So if I go the tangent of 45 degrees, I get a ratio of 1. But if I go a tangent of 225 degrees, I also get a ratio of 1. So what I need to be mindful of here is that if I were to simply go inverse tangent of 1, my calculator is only going to give me one angle, when in fact, if you're asked for angles between 0 and 360, there's probably two. So as we get started with solving trig equations, we need to keep in mind a couple of things. First of all, this point that I just described above, and that is that standard position angles with the same reference angle have the same or opposite trig ratios. This animation really drives that point home. I have a quadrant 1 angle of 30 degrees, as you can see, and what I've done is I've reflected my terminal arms across axes so that we have standard position angles in all other quadrants. But what all of these angles have in common, 210, 330, 150 degrees, is they all have a reference angle of 30 degrees. So this little slice in here between the x-axis and the terminal arm is the same in all of the standard position angles. Standard position meaning we're measuring them from the positive x-axis. And you'll notice that because these terminal arms are reflections of one another, the trig ratios, which are determined by the coordinates, are the same or opposites. The cosine ratios are all 0.87 in this case, plus or minus, and so on. And if I change the angle but keep the reference angle the same, the ratios are the same or opposites. So angles with the same reference angle have the same or opposite ratios. Now when you go about solving a trig equation, what we're going to really want to focus in on is the importance of the reference angle. That's the angle between 0 and 90 degrees. And that can be thought of as the angle that's back in quadrant 1. If we can find the reference angle for a given ratio, and then we can determine the quadrant in which a given standard position angle terminates, we can then find the angles we are looking for. And so point number 2 to remember and be cognizant of as we move ahead is that for a given trig ratio that we can do, there are usually two angles between 0 and 360 degrees that have that ratio. Using the calculator alone is only going to give us one of those angles. So to find both, what we're going to do is we're going to focus in on finding the reference angle being the angle that's in quadrant 1, that's between 0 and 90 degrees. And the ratio of all angles in quadrant 1 are positive. So if we take the inverse of the positive ratio, we will get the reference angle. And if we then have the reference angle, we can find the standard position angles we're searching for by examining the plus and minus sign of the trig ratio to determine the quadrants in which our angles terminate. Alright, let's put all this theory into practice by solving this given trig equation. We want to know what angle has a cosine ratio of negative 0.4. And we want all the angles between 0 and 360 degrees that have that ratio. If I go over to my animation and I try to make my cosine ratio negative 0.4, there we go. I see that my angles terminate in quadrant 2 or quadrant 3. And that would be because cosine is negative in quadrants 2 and 3. So by looking at the sign of the ratio, I can determine where my standard position angle terminates. Now, because there are two angles with this given ratio, let's take advantage of the fact that we know that the reference angle, which can be thought of as the angle in quadrant 1, the one between 0 and 90, is 66 degrees. And we can get that by taking the inverse cosine of the positive ratio of negative 0.4. So inverse cosine of positive 0.4 will give me, as I can see on my animation, 66 degrees. I'm going to store this number for future use. So I'm going to go with the store button in the lower left, alpha A. Just hang on to that right there. So just in terms of presenting my work, I had to consider what quadrants the angle was in. Cosine, which is x over r, and remember the radius is always positive. Cosine is negative when the x-coordinate's negative, which is in quadrants 2 or 3. And what both of these standard position angles have is a reference angle that's the same. And we can get that reference angle by taking the inverse cosine of the positive ratio, 0.4. And on my calculator that came out to be 66.42 and a bunch of other numbers degrees. So I'm just going to write down some numbers there. I'm not going to round the final answer off because now I need to go and find my standard position angle. The angle here is going to be 180. Take away the reference angle. Whereas in quadrant 3, it's going to be 180 degrees plus the blue piece, 62 degrees. So to get my two angles, I'm going to go 180 degrees minus alpha A, which is where it's stored, rounding it off to 2 decimals, 113.58 degrees. Or it could be 180 plus alpha A, 246.42 degrees. And if I take either of these angles and substitute them back into my equation, so the cosine of 113.58 degrees should be negative 0.4. It's close. Remember, we rounded off, so it won't be perfectly exact. And the other angle, 246.42, same. Okay, a second problem. This time we're asked for all angles between 0 and 360 degrees that make the sine ratio equal to negative root 3 over 2. And this time we want to solve exactly. So we will once again look at the sign, S-I-G-N, of this ratio. And sine is negative, sine being the y over r ratio. Sine is negative when y is negative, because the radius is always positive. So in my coordinate plane, the y-coordinate would be negative in quadrants 3 or in quadrant 4. And again, what these two angles have in common is that they both have the same reference angle. So if my ratio is y over r, negative root 3 over 2, I can think of the y as being the negative root 3. The hypotenuse or the radius is 2 in both of them. And hopefully as I'm writing these down, you are realizing that these are the ratios that belong to the special 30, 60, 90 degree triangle that we studied earlier. 30 is across from the 1 and 60. And so what I'm realizing from this is that this angle in here in black, the reference angle of the standard position angle we're being asked to find is 60 degrees. So we found our quadrants, we found our reference angle, this case by recognition that those ratios were part of a special triangle. And thirdly, we find the angle. In quadrant 3, it's going to be 180 degrees plus our reference angle of 60, 240. And in quadrant 4, it's going to be 360 degrees, take away the reference angle, or 300 degrees.